Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we will be discussing ICSE Class 10 Physics Chapter Work, Energy, Power. We will be discussing topic Conservation of Energy and solve problems from 2B and 2C. Hope you all are ready for the session. Let's begin. Principle of conservation of energy. We have studied about energy and what are the different forms of energy. We have discussed about the mechanical energy and the two forms of mechanical energy, which is potential energy and kinetic energy. According to the principle of conservation of energy, we have energy can neither be created nor be destroyed. It can only change from one form to another. The statement you all have studied before, right? Energy is something that cannot be created. It cannot be destroyed. It always exists. What is the change that is happening? It can be transformed from one form to another. That is, potential energy can become kinetic energy. Kinetic energy can change to potential energy. Now we have studied the different forms of energy, solar energy, light energy, hydro energy, thermal energy, different forms of energy we have studied. After which we have studied the converting energy from one form to another. We have studied, right? There are different things, that is chemical energy can be converted to light energy to heat energy to electrical energy. We have discussed them in detail. So this is what the statement is. According to the principle of conservation of energy, energy is something that cannot be created nor it can be destroyed. Only thing that is happening is a transformation of energy. Energy changes from one form to another. We know that total energy or total mechanical energy is the sum of potential energy and kinetic energy. Okay, if we have some amount of mechanical energy, it includes both potential energy and kinetic energy. If the kinetic energy is 0, then there is only potential energy. Mechanical energy will be potential energy. If potential energy is 0, then mechanical energy will be equal to the kinetic energy. Okay, we will be discussing this in detail. Now remember the statement for the principle of conservation of energy. Okay, next is a theoretical verification of potential energy plus kinetic energy is equal to constant. This constant is mechanical energy. For a freely falling body, we know that when you drop a ball towards the ground, what happens? That is, the body is freely falling. Okay, initially it will be at a height. Finally, what happens? It will be on the ground. Then what is happening here? We know that the potential energy is completely getting converted into kinetic energy. We know that mechanical energy is something that is always conserved. Okay. Here potential energy changes to kinetic energy. Now consider a body of mass m. Here we have a body of mass m at position A. Okay, it starts falling freely. When it starts falling freely, what is happening? The height, it is initially placed at height h. Height is decreasing. Okay, it has traveled through a distance x. Okay, it has fallen through a distance x. This distance is x and reaches a position B. Then what is its height from the ground? Total height is h. Okay, it has moved through a distance of x. Then h minus x will be the height at which the body is at point B. Even after some time, what happens? Again, it falls to the ground. That is your third position. Okay, you have an initial position, a mid position, and your final position, which is the ground. When it falls to ground, what happens to height? Height becomes equal to 0. At the ground, height becomes equal to 0. Okay. Now, what about the velocity? We have said about the height. Potential energy is something which depends on its position. That is, it depends on the height. Now, what about kinetic energy? Kinetic energy, we know kinetic energy is something that is depending on the motion, depending on velocity. Okay, here initial position, there is no velocity because the body is not moved. When it starts falling, what happens? It starts gaining velocity. Velocity starts to increase. Because of this increase in velocity, what is happening? Kinetic energy is also increasing. Okay, so at this position, let us take V1 is the velocity. At point B, velocity is V1. Okay, ground. When it reaches the ground, let the velocity be V. That is C position. Okay, now consider each position. What we are going to prove? When we add kinetic energy and potential energy, we should get a constant. That is the total energy. That is sum of kinetic and potential energy at A, sum of potential and kinetic energy at B, sum of potential and kinetic energy at C. Should be having a same value. Okay, should be a constant. First, let us take the first position. That is at position A. We need to separately find what is kinetic energy and what is potential energy. In this case, what is potential energy? Potential energy U is equal to, how to find potential energy? Mass into acceleration due to gravity into height. Okay, here what is the potential energy? Mass, a body of mass m, acceleration due to gravity is always g, and the height is h. Therefore, at this point, U is equal to mgh. Okay, mgh. What about kinetic energy? Kinetic energy at point A. What is the kinetic energy? How to find kinetic energy? Half mv square. Okay, here mass is m. What about velocity? V square. We know that at this point, initial point, there is no velocity, body is at rest, which means V is equal to 0. Velocity is 0. 0 square, that is 0. Kinetic energy is equal to 0. Now, the total mechanical energy. Mechanical energy, which is the sum of potential energy and kinetic energy. Here, mgh plus 0, which is equal to mgh. Okay. So here mechanical energy or total energy is equal to mgh. So this is our first part. We got the total energy is equal to mgh. Clear? Okay. This is at point A, at position A. Next, we'll move on to position B. At position B. First, we need the potential energy. What is the potential energy here? Potential energy depends on height. Potential energy U is equal to mgh. Here, what is h? Height. In this case, height is h minus x. The body is at the height of h minus x. It has travelled x distance. The remaining distance is h minus x. Okay. Therefore, mg into h minus x. Okay. This is a freely falling body. That is, we are not considering any external forces like friction, resistive forces. Nothing is considered. Freely falling body. That is, only depending on the potential and kinetic energy. We are calculating the mechanical energy. mgh minus x is your potential energy. What about kinetic energy? Do we have kinetic energy in this case? Yes, because the body is moving, there is motion, there is velocity, and hence there is kinetic energy. Kinetic energy K is equal to, again, half m v square, right? Half m. Here v. Velocity we have taken v1. v1 square. Now what is this v1? How can you find v1? We have studied different equations, right? Equations of motion. Tell me, what are the equations of motion? V is equal to U plus AT. S is equal to UT plus half AT square. Then third one, V square is equal to U square plus 2AS. Okay, we are going to take the third one. What is V square? Final velocity. At this position, final velocity is V1. V1 square is equal to initial velocity. Here, initial velocity from where the body is coming. Initial velocity is 0. Okay. 0 square 0. 2. Acceleration is acceleration due to gravity. Therefore, G. S. S is the distance. Okay. S is the distance or the displacement. Here, how much the body has moved? X distance it has moved. So, X. Therefore, V1 square you will be getting 2gx. Okay, 2gx. Now the kinetic energy is equal to half m v1 square. v1 square is 2gx. 2gx. 2 and 2 can be cancelled. Then what do we get? Kinetic energy is mgx. Now tell me what is the total energy in this case. Total mechanical energy is equal to, again, potential energy plus kinetic energy. mgh minus x plus mgx. That is equal to mgh minus mgx plus mgx. What I have written? I have removed the bracket and multiplied. Okay. This mgx and minus mgx can be cancelled. Then we will be having remaining mgh. Okay. So we have total energy is equal to mgh. The first case, that is first position and second position, we are getting total energy is equal to mgh. Now let's move on to the third position. Okay. Third position at position C. We need the potential energy first. What is the potential energy here? Potential energy is mg into height. At this point, at the ground, what is height? Height will become equal to 0. Therefore, mg into 0, which is 0. Potential energy is 0. What about kinetic energy? Kinetic energy is half m velocity square. Here the velocity is v square. Now we need to find what is v square. Okay, how to find v square? Same thing we are going to use this one. This equation of motion we are going to use. That is v square is equal to u square plus 2as. Here v square is the final velocity, which is v. V square equal to initial velocity. Body starts from here where the initial velocity is 0. 0 plus 2 acceleration due to gravity and the total distance traveled or total displacement. Here the total displacement is h. 2gh. Therefore, we will get v square is equal to 2gh. Now substituting k is equal to half m v square. In place of v square, we will be putting 2gh. 2gh. 2 gets cancelled. Then again mgh is the kinetic energy. Now what is the total energy? Total energy is potential energy plus kinetic energy. Potential energy is 0 because height is 0. Plus kinetic energy mgh. This total energy is equal to mgh. So this is the third one. At each position what we are getting? Total energy is equal to mgh. mgh, which is a constant. Okay, sum of potential energy and kinetic energy. U plus K is always equal to a constant, which is mgh. This is a proof. Okay, this is a theoretical verification. Till now we were saying that mechanical energy is always the sum of potential and kinetic energy. This is how you can prove it. Only not in these three positions. Let it be any position. If you are taking this position or this position or this position. At any position, when you calculate, you will be getting total energy is equal to mgh. Clear? Which is the initial potential energy. At the initial point, what is the potential energy? Will be the total mechanical energy at any position. Clear? Here we have some points to remember related to this. Sum of potential and kinetic energy is equal to total mechanical energy. Okay, and this is a constant value. First one is, if there is only an interchange between potential energy and kinetic energy. Now, previous example, that is falling ball. Freely falling ball, there is a complete change of potential energy into kinetic energy. In those cases, the total mechanical energy, that is sum of potential and kinetic energy, you remains a constant. We are getting a constant value. What was it? mgh. Okay, in the absence of all kinds of frictional forces. Remember this point. If all the frictional forces, air resistance, etc. are absent, then the sum of potential and kinetic energy will always be a constant. Okay, this is the first point. Second, total mechanical energy always remains constant at each point of motion and is equal to the initial potential energy at height h. Initially when we started, we had potential energy and the kinetic energy was 0. So at that point, the total mechanical energy was equal to mgh, which is the initial potential energy. When the body is falling at all the position, let it be the position B, position C, whatever it is, we are getting mgh. We have just used 3 position. At all these 3 position, we are getting mgh. What is mgh? mgh is the potential energy at the initial position. Okay, at any point you will be getting this initial potential energy value. Clear? Now the third one, as the body falls, potential energy decreases and kinetic energy increases. You understood this? When we started, we had potential energy. When it reaches the ground, the body reaches the ground, what happens? Potential energy will become 0. What about kinetic energy? Initially, kinetic energy was 0. But at the ground, what happens? Kinetic energy will be equal to the initial potential energy. Okay, that is the maximum value. Here, this point is when the body falls. What is happening to potential energy? Potential energy is decreasing. What about kinetic energy? Kinetic energy is increasing. Okay, this is the difference. Next, kinetic energy of the body on reaching the ground is equal to potential energy at the height. The point we have discussed already. Okay, initial potential energy is the kinetic energy, final kinetic energy. Clear? So remember these points. Next is ball thrown vertically upwards under gravity. We have discussed a case when a ball is under free fall. Ball is falling down. What is happening in this case? Potential energy. What is happening to potential energy? Potential energy is decreasing and kinetic energy is increasing. Okay. Now the opposite case, that is a girl is throwing a ball upwards. Okay, here again let's consider 3 positions. A position, B position, C position. Okay, at these 3 positions, what is happening to potential and kinetic energy is what we are going to discuss. Okay, initially when you throw a ball upwards, consider the case that is when a ball is released from a height. We don't have to put some energy there. That is, velocity can be 0. Velocity is equal to 0. Just we are releasing. Okay. But to throw a ball upwards, you should apply some force. There should be some velocity. Only then it can move upwards or it will be falling down. So here there will be a velocity. Okay. We'll take the velocity as V. With the velocity V, the ball is being thrown upwards. Then what happens at point B? What is happening here actually? Initially there is velocity. At some point what happens? The body will come to rest. The ball will come to rest. Why? Why is it coming to rest? What is happening here? At this point, the velocity will become equal to 0. Okay. At this point, velocity will become equal to 0. So the maximum height is when the velocity becomes 0. After that, what happens? The ball will start falling down. What is the reason? Because the gravity is acting. Gravity. Because of gravity, the body will start freely falling. So to travel from here to here, initially there is a velocity. Okay. What happens then? The velocity goes on decreasing. Velocity decreases. Okay. So at the first point, initial point, at point A. At point A, the total energy or total mechanical energy will be equal to the kinetic energy at this point. Now here, from this point, we will be considering the height. In that case, height will be equal to 0. Yes, height will be equal to 0. Height is 0. Therefore, potential energy will be 0. At this point, there is no potential energy. At the initial position, there is no potential energy and all the mechanical energy is the kinetic energy. Okay. Clear? That is half mv square itself. Half mv square. Okay. Next, the second point, B position. When it reaches B position, what is happening to the velocity? Velocity is decreasing. I am not saying that this is a midpoint or something. Well, just to understand, velocity will be decreasing. What about height? At position B, velocity at point B. At point B, what happens? What happens to velocity? Velocity decreases. What about height? Height is increasing. Okay. The body has moved through this much distance. Okay. Therefore, there is an increase in height and a decrease in velocity. Decrease in velocity. Which energy depends on velocity? Kinetic energy. Therefore, kinetic energy is decreasing and potential energy is increasing. Okay. Kinetic energy decreases, potential energy increases. Clear? So, we have reached this point. Again, the total energy will be the same. Total energy will be the value which was at the initial point. Next, again the body is traveling and reaching the final position at point C. At point C, we understand that the body is at maximum height. There is no velocity. No velocity means V is equal to 0, kinetic energy is equal to 0. Now, the total energy depends only on the potential energy. Potential energy will be equal to mgh because the body has reached the maximum height. Okay, potential energy will be equal to mgh. And therefore, the total energy depends completely on the potential energy. Kinetic energy is 0. Here, what is happening? Initially, there was kinetic energy only. This kinetic energy is getting completely changed to potential energy. In the previous case, it was initially there was only potential energy. This potential energy, when it reaches the ground, when the ball reaches the ground, gets completely converted into kinetic energy. Here, this is just the opposite case. Clear? Next, we have a table showing kinetic energy and potential energy of a body in vertical motion. Vertical motion, we are including both the free fall, that is downward motion, and throwing up, a ball which is thrown up, that is upward motion. So, when the body is in free fall, we have discussed the case. Initially, we have a height h. Okay, so here in the first column, we have height above the ground. At what height is a ball above the ground? Then you have kinetic energy, potential energy, and total energy. So, initial position, that is point A. What is the height? H, maximum height. Then there is no kinetic energy because body is not in motion. There is no velocity. Okay, velocity is equal to 0. Therefore, kinetic energy is 0. What about potential energy? Maximum potential energy, which is mgh. And total energy depends on potential and kinetic energy. It should be equal to mgh. Now, come to the second point. Here, we have taken h by 2. This midpoint. Okay, middle point B. We have discussed this with x. What was x? X is the distance. How much distance it has traveled. When it is a middle point, we will be having h by 2. Okay, when it is h by 2, how do we find the kinetic energy? Here it is given half mgh. How do we get this half mgh? We have the equation v square is equal to u square plus 2as. Okay, here initial velocity is 0. Then v square will be equal to 2g. What is s? How much distance it has traveled? Here it is given h by 2. h by 2 is the height. If h by 2 is the height, middle point, already it has traveled a distance of h by 2. Okay, therefore, here distance traveled will become h by 2. Okay, v square is equal to 2g h by 2. 2 gets cancelled, you will be having gh. Now, what is kinetic energy? Half mv square. V square is equal to gh. Substituting, we get half mgh. This is how you are getting half mgh. Kinetic energy is half mgh. What about potential energy? mgh is a formula to find potential energy when height becomes h by 2. What happens? You will be getting mgh by 2, which can be written as half mgh. What is the sum then? Total energy will be equal to potential energy plus kinetic energy, half mgh plus half mgh. mgh is common, half plus half is 1. This is how you are getting mgh. This is your second position. Now, the third position, which is ground. At ground, what happens to height? Height becomes equal to 0. Kinetic energy, what happens? Here kinetic energy will be, here in place of h by 2, you will be having v square is equal to 2gh. Okay, v square is 2gh. Therefore, kinetic energy will be equal to half m into 2gh. 2 gets cancelled, mgh. Okay, this is how you get mgh. What about potential energy? When height becomes equal to 0, potential energy automatically becomes 0. Total energy is again mgh. Okay, so this is a downward motion. Next, upward motion. Upward motion, initially starting from ground. Height will be 0. Height is 0. What about kinetic energy? Maximum kinetic energy, right? Which is equal to the potential energy at the final point, at the maximum height. It will be equal to mgh. Again, how are you getting this mgh? We have formula. Same thing we are using. That is v square is equal to u square plus 2gh. Now here what happens is, our formula is v square is equal to u square plus 2as. At the initial point we have velocity. Final point, what is the velocity? 0. So this becomes 0 and we have velocity v square. Okay, plus 2 into. Now the body is moving against gravity. Force of gravity is acting downward. Body is moving in the upward direction, opposite to gravity. It becomes minus g. Height is, total height, it will be traveling. What is it? That is h. Okay, then what do we get? V square. V square will be equal to 2gh. 2gh is a V square. Then what is half mv square? Half mv square will be equal to half m into 2gh. 2 gets cancelled. Then you get mgh. This is how you are getting mgh in this case. Okay. Kinetic energy is mgh. Potential energy will be 0. Why? Because height is 0. Clear? Total energy is mgh. Now when it comes to the middle point h by 2. Same thing. Same thing is happening here. You will be finding kinetic energy. In place of velocity square, you will be having the thing what we got here in this case. Okay, that is gh you will be getting, which will be equal to half mgh. This is how you will be getting half mgh. Potential energy when calculated. Mass into acceleration due to gravity into height. Height here is h by 2. Therefore, mgh by 2. Total when taken, half plus half becomes 1. Again, mgh you will be getting. Okay. Now, at the maximum height, at point A, what happens to kinetic energy? Kinetic energy will become 0. Velocity is 0. What about potential energy? Maximum height, maximum potential energy, which is mgh. Total energy will be mgh. Clear? Understood this? Here in all these cases, velocity we are writing in terms of height. V square is equal to u square plus 2as. Using this equation of motion, we will be converting the velocity part in terms of height. Okay, using this, I will be showing you how to plot a graph. Okay, a graph which shows a relation between energy and the height. Okay. So we will be having the x-axis and y-axis. This is your x-axis, this is y-axis. In the y-axis, we will be taking energy, and x-axis we are taking the height. Just we are considering 3 position. Initially when height is equal to 0. Second position when height is h by 2. Third position when height is h. Okay. What about energy? Energy, maximum energy, we will be taking as mgh. We know maximum energy is a maximum potential energy, mgh. So take all these positions. First we will be considering the downward motion. In case of downward motion, when the height above the ground is h, maximum height. Okay. At maximum height, what is the total energy? We just need the total energy. Total energy is mgh. Okay. So at maximum height, total energy is mgh. This point you will be getting. Okay. What about the second point, h by 2? At all points, what we are getting? The total energy is mgh. We need the difference, kinetic energy and potential energy. So at all these points, whether it is 0, h by 2h, downward motion or upward motion, you will be getting mgh. Okay. What does this mean? The sum of potential energy and kinetic energy at any point, at any height will be a constant, and this constant is what mgh is. Now in terms of potential energy and kinetic energy, we are going to plot this graph. Okay. So first position at point h. In case of downward motion, what is the kinetic energy? Kinetic energy K is equal to 0. Okay, we are taking the case of downward motion. Where do we have 0? Kinetic energy is 0. At what height? At the maximum height. Maximum height here. Okay. Kinetic energy is 0. So this is the point. Okay. Energy y-axis is 0. X-axis h. Next, second position. At point h by 2, B position. What is the kinetic energy? Kinetic energy is equal to half mgh. Here we have total mgh. Half mgh will be somewhere the half. Okay. This point is when we have height h by 2. h by 2, half mgh. This is the point. Next, kinetic energy at the third position. When body is at point C, height will become equal to 0. Their kinetic energy is mgh, maximum kinetic energy, this point. Okay. When you draw a straight line through all these points, this is how the change in kinetic energy, okay, change in kinetic energy is shown. This is how kinetic energy changes. Clear? At maximum height, at h by 2, h 0, what is the kinetic energy? Next, we'll go to potential energy. Okay, what about potential energy? Downward motion, potential energy at height h. What is the potential energy? potential energy is mgh. At height h, potential energy is mgh. Okay. Next, at height h by 2, potential energy is half mgh. Half mgh, here we have half mgh. H by 2 is the height. So this point again you are getting this point. Next, third position, that is at C point where height becomes 0, potential energy becomes 0. Okay, height is equal to 0, potential energy 0. Height is 0 this point, potential energy is 0 this point. Okay, when you join these points, you will be getting the potential energy variation. So what is happening to potential energy? From height h to 0, potential energy is decreasing. What about kinetic energy from height h to 0? Kinetic energy is increasing. Okay, this is the case of downward motion. Now take the upward motion. Is there any difference? Let's find. Upward motion. At the first point 0, kinetic energy is mgh. At first point 0, kinetic energy is mgh. Same thing. Okay. Second point, h by 2, kinetic energy is half mgh. h by 2, kinetic energy is half mgh. At point A, height is h, then kinetic energy is 0. Height is h, kinetic energy is 0. The same point, same is the case of potential energy. Potential energy, what is happening? Initial potential energy when height is 0. Potential energy is 0, this point. Okay. Then when height becomes h by 2, potential energy half mgh, this point. Third, height is h, potential energy is mgh, this point. Okay. So this graph shows the variation of potential energy and kinetic energy. Total energy is a constant which is mgh at any height. At 0, h by 2, whether it is h by 4, 3h by 2, whatever be the height, total energy is always conserved, which will be equal to mgh. And this straight line parallel to the height axis or the x-axis shows the constant. Okay, it shows that this energy is a constant. Okay, understood how to plot this graph? So this is our last topic of this chapter, application of principle of conservation of energy to a simple pendulum. We have applied principle of conservation of energy for a freely falling body and a ball that is moving upwards, a ball thrown upwards. Now the case is conservation of energy, principle of conservation of energy in case of a simple pendulum. You know what a simple pendulum is. This is the initial position of the pendulum. Let us take this as A. Okay, we call it mean position. This is mean position. Now what happens is, when you pull this bob and release, what it happens? It starts swinging. Okay, let us take this point as B and this point as C. Initially, when you pull it to this point, what is happening to energy here? Just try to understand. Here what happened? Initially there is no energy. When you pull it up and reaches this position, it is at a height. It has moved a height. Okay. When there is height, you will be having potential energy. Correct. At this point, the bob is having a potential energy mgh. Okay. Now, at the same point, what about kinetic energy? Potential energy is mgh. At this point, the bob is not moving. The bob is at rest. We are not releasing it. It is not in motion. Therefore, velocity will become equal to 0. At point B, velocity is 0. Then kinetic energy will be equal to 0. The total energy at this point B depends only on the potential energy because the bob is at its maximum height. When you release, what happens? The body starts moving. It will start having velocity. It will be having kinetic energy. Okay. From B, it reaches back to A. When it reaches back to A, it is the main position. At the main position, what is the height? There is no height moved. Height becomes equal to 0 and hence potential energy will be 0. What about kinetic energy? Here, there is action of gravity as well. So, here the stored potential energy should get converted into kinetic energy because the body is moving. Moving body will be having velocity. So, it doesn't stay here. What happens? It will be moving to the point C. Why? Because it is having a velocity, right? There is no height. Height is 0, but there is velocity. And this velocity will be maximum at the mean position. When the velocity is maximum, when the body is in motion, there is kinetic energy, and this kinetic energy value will be the maximum potential energy at the point B. it will be equal. That is the same case of free fall. In free fall, what has happened? The potential energy gets completely converted into kinetic energy. Same thing at the mean position and extreme position. When we take extreme position, there is only potential energy. At the mean position, there is only kinetic energy. So the body which has reached this position, what happens to it? Because of its kinetic energy, it starts moving to point C. Okay, point C is a point similar to point B. Here there is no velocity. When it reaches here, what happens? This is a maximum height and it starts moving to the same point A. It cannot move further upwards. This is a maximum height it can reach. Maximum height. Again, there is potential energy, mgh. What happens to kinetic energy? When it reaches the maximum height, it is because the velocity has become 0. If there is still velocity, it can move forward. But the velocity has become 0. Therefore, kinetic energy is 0 at this point. So, at position B and position C, what is happening? Kinetic energy is 0. Potential energy is mgh. When you take the mean position at point A, what happens? There is no height, there is no potential energy and the total energy is always mgh. Why? It depends only on the kinetic energy. Clear? So, this is a case of a simple pendulum. So, if you are taking any other point between the mean and extreme points, okay, you are taking a point which lies between the mean and extreme point. Somewhere here you are considering a point. In that case, total energy, does it depend on potential or kinetic energy? Tell me. At this point there is height. The body is moving, there is velocity, which means since there is both height and velocity, at the point which lies between the mean position and the extreme position, there is both height and velocity. Therefore, it will be having potential energy and kinetic energy. Okay. So, the total energy will be the sum of potential energy and kinetic energy. At the extreme points, total energy is potential energy. At the mean points, potential energy will become equal to 0 and kinetic energy is the total energy. Anywhere between them, that is between mean and extreme point. What is having? Extreme point, there is maximum potential energy, mean point, maximum kinetic energy. So, what happens? The potential energy goes on decreasing. Potential energy goes on decreasing, kinetic energy goes on increasing. When the body moves from mean to extreme position, what happens? Potential energy goes on increasing, kinetic energy goes on decreasing. This is how when the body reaches the extreme points, kinetic energy will become equal to 0 since velocity is 0. Clear? So, this is the case with a simple pendulum. We have discussed about simple pendulum, that is application of principle of conservation of energy in case of simple pendulum, a ball which is thrown upwards and a freely falling ball. Clear? Let us solve more problems. Here we have the first problem. Two bodies of equal masses are placed at heights h and 2h. Find the ratio of their gravitational potential energies. Here we have two bodies which are of equal masses. Let us take the mass of both the bodies as m. Okay, the first body is at a height h from the ground and the second body is at a height 2h, that is 2 times h from the ground. We have to find the gravitational potential energy ratio. Okay, so here let the height at which first body is placed, h1 is equal to h. h1 we are taking as h. Okay, it is given as h. Next, the height at which second body is placed, h2 is equal to 2h. Okay, h and 2h. Next, mass of first body. We are taking both the masses as m. Mass of first body m1 is equal to m. Then mass of second body m2 is also equal to m. Now how to find gravitational potential energy? gravitational potential energy of first body. Gravitational potential energy of first body is equal to mass into acceleration due to gravity into height. Okay, here mg h1, that is mgh. h1 is equal to h. Next, gravitational potential energy of second body is equal to mgh2, which is mg into 2h. Second height is equal to 2h. Okay. Now the required ratio. Ratio is equal to gravitational potential energy of first body divided by gravitational potential energy of second body. This is how you can find the ratio. Okay, ratio means it is division. Gravitational potential energy of first body divided by gravitational potential energy of second body. What is gravitational potential energy of first body? mgh. mgh divided by gravitational potential energy of second body is equal to mg into 2h. mg into 2h. Here m can be cancelled, g can be cancelled, h can be cancelled. So the ratio is 1 by 2, which can be written as 1:2. So 1:2 is the ratio of gravitational potential energies of first body and second body of equal masses but placed at different heights, h and 2h. Clear? So we understand that gravitational potential energy increases when height increases. Gravitational potential energy depend on mass, acceleration due to gravity and the height of the body. They are directly proportional. When height increases, gravitational potential energy will also increase. Here h has changed to 2h, which means gravitational potential energy will also become 2 times. Clear? Second problem, a body of mass 5 kg falls from a height of 10 meter to 4 meter. Calculate the loss in potential energy of the body. Second part, the total energy possessed by the body at any instant. We have to take g is equal to acceleration due to gravity. G is equal to 10 meter per second square. Here we have a body at a height of 10 meter. It falls through a height to 4 meters. So this height, it has fallen and this part will be 4 meter. The ball has reached here. Okay. We have to find the loss in potential energy. We know that potential energy decreases when height decreases. Initially it was 10 meter. It decreased to 4 meter. What are the given quantities? Mass is given. Mass m is equal to 5 kg. Then acceleration due to gravity, g is given. G is equal to 10 meter per second square. Okay. Initial height. Initial height. h1 is equal to 10 meter. Okay. Then what is the initial potential energy? Or you can say potential energy at height 10 meters is equal to mgh, mgh1, that is 5 into 10 into height is also 10. Okay, 10 into 10, 100, 100 into 5, 500. What is the unit? This is an energy, therefore joules is a unit. 500 joules. Next, potential energy. Potential energy at height 4 meters will be equal to, again, mgh2. Here the second height is 4 meters. So mgh2 mass is equal to 5 kilogram. Acceleration due to gravity is same, which is 10. Height has reduced to 4 meters. Okay. 5 into 4, 20. 20 into 10, 200. 200 joules. Therefore, the loss in potential energy is equal to initial potential energy, that is the potential energy at height 10 meter minus the potential energy at height 4 meters. That is 500 minus 200 equal to 300 joules. 300 joules is a loss in potential energy. Clear? Loss in potential energy is equal to 300 joules. Okay, now the second part, the total energy possessed by the body at any instant. We know that total energy will be a constant. Total energy means is the total mechanical energy, potential energy plus kinetic energy. Here, when you consider the initial position, that is at 10 meter, we have potential energy. Do we have kinetic energy? No kinetic energy. What is the reason? Kinetic energy will be equal to 0. What is the reason? The body is not moving. When the body moves, it will be having velocity and hence it will be having kinetic energy. In this case, the body is at rest. There is only potential energy because of its position. There is no kinetic energy. So, you can consider any point. That is, in this 10 meter, you can consider any point. You can either take the ground level or you can take the maximum height or any middle portion. So, if you take the maximum height, you know the maximum height, how much it is. It is the first position, initial position. So, you can take this. You also know the kinetic energy will be equal to 0 at this point. Why? Because the body is not moving. If you take any other positions, there will be velocity. Why? When a body moves, it is having velocity and it will be having kinetic energy. So, here, when you take maximum height, okay, at maximum height, total energy is equal to potential energy plus kinetic energy. Potential energy will be equal to, again, mgh. Here mass is equal to, we have already found what is mgh, maximum height, what was the potential energy, we got 500 joules. How we are getting? Mass is equal to 5 kg, g is 10 and height is 10. Therefore, 500 joules. What about kinetic energy? Kinetic energy will be equal to 0 joules. Why? Because velocity is equal to 0. Okay. Since velocity is 0, kinetic energy will be equal to 0. Therefore, total energy is equal to potential energy plus kinetic energy, which is potential energy 500 joules plus kinetic energy 0. Therefore, total energy is equal to 500 joules at any point. Maybe at this point or this point or this point, this point. In any point when the ball is falling, when you calculate the total energy, you will be getting 500 joules. What will happen here? When the body falls, its potential energy will decrease, kinetic energy will increase. Okay. At what amount potential energy is decreasing, in the same amount kinetic energy will keep increasing. Clear? Next, third problem. A vessel containing 50 kg of water is placed at a height of 15 meter above the ground, assuming the gravitational potential energy at ground to be 0. What will be the gravitational potential energy of water in the vessel? It is also given that G is equal to 10 meter per second square. Okay. Given mass. Mass M is equal to 50 kilogram. Placed at a height of 15 meter. Height is given. Height H is equal to 15 meter above the ground, assuming that we have taken the gravitational potential energy at ground to be 0. Okay. When gravitational potential energy at ground is equal to 0, we need to find the gravitational potential energy of the vessel, which is at a height of 15 meter. G is also given. 10 meter per second square. What is gravitational potential energy? Gravitational potential energy represented by letter U is equal to mass into acceleration due to gravity into height, mgh. Okay, put the values. What is m? M is 50. G is equal to 10. H is equal to 15. 15 into 5 is 75, then 2 zeros. So 7500 joules is your final answer. Just you need to put the values and calculate, you will be getting the final answer. Clear? Next, fourth problem. A cannonball of mass 500 gram is fired with a speed of 15 meter per second. We have to find its kinetic energy and its momentum. Okay, first let us find the kinetic energy. Given mass m is equal to 500 grams. Here mass is in grams and speed is in meter per second. So we have to take the standard units. Okay, either you have to convert this grams into kilogram, or you have to convert this meter per second into centimeters per second. So better converting this grams to kilograms. What is 500 grams into kilograms? We know 1 kilogram is equal to 1000 grams. Which means 1 gram will be equal to 1 by 1000 kilogram. Here we have 500 gram, which means 500 gram will be 500 into 1 by 1000 kilograms. How much do we get? You will be getting 500 grams is equal to 0.5 kilograms. Okay, 500 grams is equal to 0.5 kilograms. Next, we have the speed given. Speed or velocity V is equal to 15 meter per second. To find kinetic energy. How do we find kinetic energy? What is the formula? Half mv square. Half mv square. Substitute half into mass is 0.5 into v square, which is 15 into 15. 15 into 15, 15 square, that is 225 into 5. How much do we get? 25, 12, 11. Okay, that is 112.5 divided by 2. On dividing, how much do we get? We get 56.25. What is the unit? It is kinetic energy. Therefore, 56.25 joules. 56.25 joules. Next, we have to find the momentum. How to find momentum? We have studied momentum is the product of mass and velocity. Momentum is represented by small letter P. P is equal to mv. Okay, we know what is mass. Mass given 0.5 kilogram. 0.5 into. What is the velocity here? Velocity is 15 meter per second. 15. Okay, 15 into 5 is 75. Okay, we have a point, therefore 7.5. What is the unit of momentum? Kilogram is the unit of mass. Meter per second is the unit of velocity. Therefore, the unit of momentum is kilogram meter per second. 7.5 kilogram meter per second is your final answer. Okay, next problem number 5. A bullet of mass 50 gram is moving with a velocity of 500 meter per second. It penetrates 10 centimeter into a still target and comes to rest. Calculate first one, the kinetic energy possessed by the bullet, and second, the average retarding force offered by the target. Here, a bullet is going deeper into a target, it is penetrating into a target. We have to first find kinetic energy. In order to find kinetic energy, what is given? Mass is given. Mass m is equal to 50 grams. Convert this 50 grams into kilograms. How much do we get? 0.05 kilograms. Okay. Then velocity is given in meter per second. Velocity v is equal to 500 meter per second. This is more than enough to find the kinetic energy. So what is kinetic energy? Kinetic energy K is equal to half mv square. Half into mass 0.05 into 500 into 500. On calculating, you will be getting 6250. What is the unit? It is an energy. Therefore, unit of energy, joules. Now, the second part, we have to find the average retarding force offered by the target. When this bullet goes inside, there will be a retarding force offered by the target. Okay, we are going to find the retarding force. The work done by the target when the body, that is the bullet, penetrates. So, against this, a work is done by the target. So, this work done will be equal to, this is against the motion of the bullet. Okay, so there you will be having retarding force into distance, how much it has penetrated. Okay, we know the work done. Work done will be the kinetic energy. Okay, that is 6250. What about the retarding force? We need to find the retarding force into distance, how much it has penetrated. Given 10 centimeter, convert this 10 centimeter to meter first. 10 centimeter will be 0.1 meters. 0.1 meters. Therefore, the retarding force will be equal to 6250 divided by 0.1. Numerator and denominator multiplying with 10, we get 62,500 divided by 1. So, the retarding force is 62,500 Newton. 62,500 Newton is the average retarding force offered by the target when the bullet penetrates. Clear? Sixth problem. A ball of mass 0.20 kilogram is thrown vertically upwards with an initial velocity of 20 meter per second. We have to calculate the maximum potential energy it gains as it goes up. So from here, a ball is thrown up with a velocity. Velocity is given, which is 20 meter per second. With velocity 20 meter per second, a ball is thrown up. Okay. When this velocity becomes 0, it stops. So it stops at the maximum height. After that, the gravity will be pulling it down. Okay. The ball will start to come down. At this maximum point, the velocity will become equal to 0 meter per second, and this is a maximum height. Okay, this is the maximum height. We know that potential energy will be maximum at the maximum height. Yes, we have to find the maximum potential energy. So maximum potential energy will be at maximum height. Okay, so at this point we know that potential energy will be maximum. What about kinetic energy? Kinetic energy will become 0. Why? Because velocity is becoming 0. Okay. Now at the initial position, the velocity is maximum. When it moves upwards, what is happening? Velocity is decreasing. That is, kinetic energy is decreasing. So at this initial point, kinetic energy is maximum. And potential energy can be taken as 0 at this point. Okay, there is no potential energy, there is only kinetic energy considered. Now, when the ball moves upwards, what happens? Its kinetic energy decreases and potential energy increases. From this, we understand that the potential energy is maximum at the maximum height, and at the initial point, kinetic energy is maximum. So, the kinetic energy at initial position will be equal to potential energy at the maximum height. Okay. Potential energy at maximum height is equal to initial kinetic energy. Okay, initial kinetic energy. How to find kinetic energy? Half mv square. Mass is given. What is the mass here? 0.2 kilogram. 0.20 is 0.2 kilogram. Then initial velocity is given. V is equal to 20 meter per second. Then what is the kinetic energy? Half mv square. Put the values. Half into 0.2 into 20 square. Okay. Kinetic energy is equal to half into 0.2 into 20 into 20. Can be cancelled. It becomes 0.1. 20 into 20 is 400. 400 into 0.1 is 40. So 40 joules is the kinetic energy. This kinetic energy is equal to potential energy at maximum height. Therefore, potential energy at maximum height is equal to 40 joules, or this is the maximum potential energy. Beyond this 40 joules, you won't be having potential energy in this case. Okay, next problem number 7. A stone of mass 500 gram is thrown vertically upwards with a velocity of 15 meter per second. We have to calculate first the potential energy at its greatest height. Second, the kinetic energy on reaching the ground. The total energy at its halfway point. Okay, here a ball is thrown vertically upwards. Initial velocity is given, which is 15 meter per second. So the ball is thrown with a velocity of 15 meter per second. It reaches its maximum height, then velocity will become 0 meter per second. At maximum height, velocity will become 0 meter per second. Okay, then the ball will be traveling downwards. Now we have to find the potential energy at the greatest height, at the maximum height, when velocity will become equal to 0. At this maximum height, we have to find the potential energy. Then we have to find the kinetic energy on reaching the ground. When the body or the ball touches the ground, what is its kinetic energy? This we need to calculate. And also we have to find the total energy at its halfway point. At the midway, it will be having both potential energy and kinetic energy. So we have to find the total energy. Let's first find the potential energy at the greatest height. Given that mass m is equal to 500 gram. Convert this 500 gram to kilogram. 0.5 kilogram. Okay. Velocity is given. Velocity v is equal to 15 meter per second. We have to calculate A part. Potential energy at the greatest height. Do we know the value of height here? Do we know what the greatest height is? No, right? At the greatest height, we know that potential energy will be maximum. And kinetic energy will be maximum when the ball is thrown. With the velocity, when the ball is thrown, kinetic energy will be maximum. So this kinetic energy and this potential energy will be equal. Potential energy at greatest height will be equal to kinetic energy, that is initial kinetic energy. We can easily find what is initial kinetic energy. We know the mass and also the velocity. So therefore that is equal to half mv square, half into mass 0.5 into velocity square, 15 into 15. On calculating this, you will be getting 56.25 joules. Okay, so the maximum height potential energy is 56.25 joules. Now the second part, we have to find the kinetic energy on reaching the ground. On reaching the ground, again what happens? Potential energy gets converted to kinetic energy. At the ground, maximum velocity, therefore maximum kinetic energy. We know the value of maximum kinetic energy. Initial kinetic energy and the maximum kinetic energy will be the same. So when the body, the ball, the stone, when it reaches the ground, the kinetic energy will be maximum and it will be equal to the maximum potential energy. That is potential energy at greatest height. For the kinetic energy on reaching the ground is equal to potential energy at greatest height. Just put the value, that is 56.25 joules. 56.25 joules. Okay. Now the third part, we have to find the total energy at its halfway point. Total energy will be equal to potential energy plus kinetic energy at that midway point. Okay. At the midway, what happens? Potential energy will reduce to half of its maximum value and kinetic energy will also reduce to half of its maximum value. That is half of maximum value here. We have 56.25 plus half of maximum kinetic energy. Kinetic energy is again 56.25. Okay. Taking half outside, 56.25 plus 56.25. Okay, 56.25 plus 56.25 can be written as half into 2 into 56.25. Now 2 and 2 gets cancelled. Again the answer is 56.25 joules. So at the midway there is both potential energy and kinetic energy. And therefore the total energy is the sum of potential and kinetic energy, which is also equal to 56.25 joules. Understood? Next, the 8th problem. A metal ball of mass 2 kg is allowed to fall freely from rest from a height of 5 meter above the ground, taking g is equal to 10 meter per second square. Calculate. First, we have to calculate the potential energy possessed by the ball when it is initially at rest. Then, the kinetic energy of the ball just before it hits the ground. And third, what happens to the mechanical energy after the ball hits the ground and comes to rest. What is given in the question? Mass is given. Mass m is equal to 2 kilogram. Okay. From rest, from a height of 5 meter, height is given, h is equal to 5 meter above the ground. G is given, that is 10 meter per second square. We have to calculate the potential energy possessed by the ball when it is initially at rest. That is the maximum potential energy. Before the ball falls at rest, because of its position, it will be having potential energy. So what is the potential energy? A part, first one, potential energy will be equal to mgh, mass is 2, g10 and h 5. That is 100 joules. Okay. 2 into 5, 10. 10 into 10, 100. 100 joules. 100 joules is the potential energy. Now the second part. The kinetic energy of the ball just before it hits the ground. When a body falls freely, here you will be having potential energy and kinetic energy equal to 0. At the bottom point, what happens? This potential energy will become 0. That is, a potential energy will completely get converted to kinetic energy. Kinetic energy will get its maximum value. So this kinetic energy just before it hits the ground will be equal to potential energy at the maximum height. Then what is the value of kinetic energy? Kinetic energy is equal to potential energy at maximum height. That is the initial potential energy. Required kinetic energy will be 100 joules because we have determined the potential energy at rest or at the maximum height. Now the third part. What is the question? What happens to the mechanical energy after the ball hits the ground and comes to rest? So once the ball falls freely, it will come to the ground. Okay, at the ground we know that it will be having maximum kinetic energy and potential energy will become equal to 0. There is mechanical energy. What happens to this mechanical energy? Anyway, the body will come to rest. We know that. What happens to this mechanical energy then? Here, this mechanical energy will get converted to two other forms. That is, mechanical energy. Mechanical energy will get converted to heat and sound. When the ball falls or when a stone falls, you will be hearing a sound. Sound is a form of energy and there heat will be produced. Okay, so it is getting, mechanical energy is getting converted to heat and sound because there is some friction happening there. Clear? Here we have the last question for today, problem number 9. The bob of a simple pendulum is imparted a velocity of 5 meter per second. When it is at its mean position, to what maximum vertical height will it rise on reaching at its extreme position if 60% of its energy is lost in overcoming the friction of air? That is, when you suspend a bob or consider the bob of a simple pendulum, this is the main position. When it is taken to the maximum height, there you will be having the extreme position. So at the extreme position, potential energy will be maximum. Here what is given? It is given that when we have to find the maximum vertical height, when it reaches the extreme position, if 60% of energy is lost in overcoming the friction, there is friction, okay? 60% of energy is lost. What energy is remaining? 40%. Okay. So the 40% of kinetic energy at its mean position will be equal to the potential energy at extreme position. Clear? Therefore, potential energy is mgh is equal to 40% of kinetic energy, which is half mv square. Okay, half mv square. We know that kinetic energy will be maximum at the mean position. Now here 60% is lost because of friction of air. Only 40% will be remaining. Therefore, mgh is equal to 40% is 40 by 100 into half mv square. Velocity is given 5 square. Okay, m and m can be cancelled. Mass can be removed from both the sides. What is remaining? G. G is 10. Then h. H we need to find 40 into 5 square 25 divided by 100 into 2. Okay, 25 and 100 can be cancelled. 25 into 4 is 100. 4 and 40, 10. This 10 and this 10 can be removed. Therefore, h is equal to 1 by 2, which is 0.5 meter. Okay, the maximum vertical height is 0.5 meters. Maximum vertical height, it has been raised, is equal to 0.5 meters. Okay, that's all for today. In today's class, we have discussed the principle of conservation of energy and its application to a freely falling body, a ball that is thrown upwards, and in case of a simple pendulum. We have also solved many problems. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.